Greetings and welcome back. If you had a longer break and during the longer break you had a chance to look at the scoreboard or the leaderboard of the CTF, you would have noticed that there has been a lot of significant changes. Now the tension is up because we have only just few hours, actually 1 hour left until the CTF is over, so there's a battle for the first 3 positions. We, the CERT.LV, welcome you back here to the studio, and we are getting ready for the next speaker. Now, the next topic ties in the spirit of the conference, not only from the defensive perspective, but also from the slightly offensive perspective. Now, if you are in the red teaming or you are doing offensive security, the next talk is right for you. Now, we welcome to the studio our next speaker, Gil. Welcome to the studio. And
Hi.
Without the further ado, the cyberspace is yours.
Thank you very much. Hi, everyone. My name is Gil Biton, and I'm very excited to be here. I want to discuss today with you how we solve red team challenges in our team. I will also share with you the framework that we're using to automate repetitive red team tasks and enable you to do and use the same framework in your teams. Before we start, a bit about myself. I'm an offensive security engineer and researcher working at Sygnia Consulting, where we provide security services from any type of aspect. We protect huge organizations through security postures, red teams, adversary simulations, incident response, threat hunting, and continuous monitoring. Actually, today I am celebrating over 6 years in the cybersecurity industry, and not counting hacking games more than 10 years ago. I went all the way through application penetration tests to infrastructure engagement, through and red teaming. I mostly focused on enterprise security and the related aspects of it. I listed here my social networks where you can connect with me and feel free to ask questions, especially when Facebook is not operational. Let's start. So before we show the demo and the next things, I want to share with you the context of being an offensive security or adversary simulator or red teamer. We strive to do even better than the threat actors and not just mimicking them, because we want to challenge the clients, the organizations that we are trying to protect, and we also need to sometimes invent ourselves. So as of that, the first thing I wanted to share, and I'm pretty sure that red teamers out there will agree with me, is that the red and purple teaming operations became harder than the past years. And this is because organizations being more aware of cybersecurity, and they are implementing and incorporating a lot of monitoring logs, EDRs, abnormal network detections, and so on. As a result, it caused for to take control of an organization to find gaps. It made the weaponization of the tools we're using for collection exploitation, the duration of preparing them and weaponizing them and transferring them to the targeted network, it stretched the time to do that. And it comes from like few minutes where you just had to download the executable and run it, or build it from source, to few hours or even a day, where you find yourself trying to weaponize a tool through encoding it, obfuscating it, sometimes solve compiling problems, and so on. So this task is not also takes time. It's also repetitive when you do this across different tools. So there is also a big team in our offices that are performing multiple engagements in the same time. And each engagement brings its own challenges. And I'm pretty sure that anyone in the team are doing best when they solving different challenges. But it's very hard to collaborate. And sometimes you just find a new thing in a new technology. And without having a hour session every morning with the whole team, you may miss a lot of things. Also, when we do share things between us or from things that happen in the cybersecurity industry, let's say from Twitter or things that are posted to GitHub, it became harder and complicated to memorize it. And we try to store it in a way that will be easier for us to pull it back and use it when we in a need, in the middle of an engagement, for example. The security industry already adopted CI/CD concepts in order to automate tasks that are related to red team tools of weaponization. Now, I'm not going to talk in detail about CI/CD, but I'm going to show you the advantages of using it for offensive needs. I truly believe that we cannot automate the entire team operation because we need someone on the other side to receive the feedback from the server and the infrastructures and to determine what is the next step to do. We explored the CI/CD area and we decided that we want to first define the needs for the type of our team. Such needs included simplicity, because we didn't want to do a more headover to our work and have like a not organized approach to start and store and use CI/CD concepts where we need to teach everyone and like taking a lot of time for people to develop some new thing they did and incorporate into the CI/CD. The CI/CD that we explored we were also seeking for modularity, because there are many tools and techniques that comes out every day, many CVEs. You may see like last July there were like 3. And we have to build it in modules. So we can take one tool or few techniques and pass the tool through a flow that will weaponize it and prepare it before we transfer it into the targeted environment. We also looked for a framework that will be able to maintain itself. So we won't need to put someone's time in maintaining it. The system has also to be collaborative. As I say, I want people to express their thoughts, their tools, their code, the things, the new things they find, but still we need somehow to store the backlog and also the things that they create incorporate into the new and production environment that cause the flow of weaponizing the tools. Also, it has to be self-managed, because we are weaponizing tools that are considered malicious. And we don't want them to get flagged or having them on a SaaS solution CI/CD that we cannot control its infrastructure server, either it has EDR or antivirus. And also because many times you're in a need for a tool in the middle of your operation, of your engagement, you don't have much time to weaponize it. It must be an on-demand need, both for serving multiple people on multiple engagements and also for new tools to come. After considering all these needs, we ended up choosing GitLab as the core of our framework. From its high-level description, we can predict that it might fit the needs, but we also went to look at the technical aspect. And GitLab started off being a version control, and you can store the techniques and tool as a code with commits, which is great for backlogging and history. It comes with a RESTful API where basically anything you can do via the UI, you can do through API calls, which is crazy. The API comes with a detailed documentation where you can find anything you need. Of course, we need the GitLab CI/CD, where you can build your YAML format pipeline flows, which I will refer as recipes, and in an organized and simple way. There is also integration to run your jobs in a Docker or Kubernetes. And this is very useful because most of the things you need for weaponization is tools that require dependencies. And having them through containers, images, can be a great solution for disposable environments and a fast approach to get into the installations you need. There is also a rule-based job triggering where you can trigger pipelines on a specific CI/CD pipelines on specified conditions. It can be whether you pushed a new code into the repository, or when another pipeline ends, or by another pipeline. The multi-pipeline support of GitLab allows you to trigger a few pipelines through executing only one. And if we divide each and every tool to one repository, which will present one pipeline, we can actually trigger a set of, let's say, reconnaissance tools at the beginning of our engagement with few clicks. Let's move on and see the infrastructure that we built to support this kind of approach. We started off having a GitLab server, which comes with its built-in CI/CD. We decided to run our jobs, to run the specific tasks we need for each and every step to weaponize a tool on a Kubernetes cluster, where we bring Linux node pool and Windows node pool. And these node pools are related to the tasks we need, because sometimes you really need Windows, where although it's not so convenient with the containers, you need because eventually you will run and execute your tools on Windows. It can be used for testing, it can be used for building, and other things that are programmed to Windows. To connect between the GitLab instance and the Kubernetes cluster, GitLab created something called GitLab Runner, where it acts like an intermediate proxy that takes the jobs from your GitLab instance and instructs the Kubernetes cluster to schedule the pods which containing all the scripts of your job on the according to the operating system you need on the related node. It can also, of course, as part of Kubernetes features, it can also scale to few nodes. So basically, you can weaponize thousands of tools or tools to the whole community in few minutes. GitLab, we also created the GitLab Runner for the Linux related jobs. So we will be able to pick up on which operating system we would like to execute our jobs from the job definition. The Kubernetes cluster is connected to our container registry, where we store our customized containers for jobs related to building or obfuscating or encrypting or proprietary things we made, or things that we just took from the public community and Dockerized them. We aim to build this thing in this infrastructure on our Google Cloud platform, where we use the related GCP services. We also added the cloud storage for storing utilities we need throughout the way, and also had the network and the firewall rules to allow our team to operate it. And this is the single point where you will need to operate this entire framework, because it's automated, it maintains itself. Eventually, the GitLab will be able to pull remote Git repositories from the internet where you can use as the techniques or tools to weaponize and attack the target environment. We packed everything into a Terraform script, which comes in a platform in part of the Scalps framework that I mentioned. You can actually use it by yourself by referring to the project's repository, follow the instructions. All you need is a GCP subscription, project in a GCP, and a web browser. Once we're done, now that we're done, we can go to the demo and show you the benefits of this kind of framework. So let's start. First, we have the repository where we have the instructions of how to deploy the framework together with all the guide I showed into our GCP. I created a GCP project for that. And there is only a specific GCP protocol, and there is only one instance here, which acts as the file server where we will send our outputs artifacts after obfuscating them to that server. So this is the only server I have in this environment. The Kubernetes cluster is still empty. I have a few container images that I uploaded beforehand to save some time. And also, the storage basically reflects the container registry as a bucket. So this is just the way Google Cloud works. And we have the secret manager where we store passwords and secret keys related to the framework. We fire up the Cloud Shell, cloning the project, and we will need to edit the configuration file to fit to our parameters. As you can see, the mandatory parameters are the project ID, which is the project ID from your GCP, and infrastructure name, which is any name you wish to, just has to fit the regex, and operator IPs, which is your external IP address where you, so you will be able to authenticate and access the system. The system will not be accessible. No one in the internet will be able to communicate with what you're doing. The info name will be demo1, save the file. And now we'll have to initiate the Terraform. And deploy the resources. We have to authorize it to for accessing our GCP cloud project. We need to have owner permissions because we're playing with secrets. Hitting yes, and this operation should take around 8 to 10 minutes. As you can see, it starts putting the resources in the cloud. They're around 50. We will skip that phase. Okay, now we got the output of the GitLab external IP address. We also have the secret that stores the password to our GitLab instance. So the administrator, default administrator user is root, and the password will be at the secret manager under the name demo1 GitLab root password. Demo1 will be the prefix. By refreshing the secrets manager, we can view the secret and copy the password. Authenticating to the framework, we can see that the scallops recipe is already imported into our GitLab. And we can see that it's the scallops recipes. So the Scalops repository is the one acting as the deployment, the infrastructure, the Terraform, and the Scalops recipes is the set of YAMLs we're using in order to create the flow for our pipelines. And we structured it in a way we think would be the best way to make it easier for people to modulize it and make it readable in the same flow. So the first thing we have to do after deploying this environment is the deployment init pipeline. The deployment init pipeline checks that as a health check. It checks that we checks for the Linux and Windows server. It checks for variables. It builds the container and import a list of public tools that we defined. Now we will take a look what is behind these jobs that we just saw. I really like to use the GitLab's Web IDE also for exploring and testing new things, new codes that I'm doing here. By default, GitLab uses .gitlab CI YAML for the pipeline you're running from any repository. And here we have the inclusions of other YAMLs we're using in our jobs, together with their stages, which comes one by one. Now, the OS triggers created the jobs that checks whether we have an operational Linux server that we can schedule pods to it, and also operational Windows server that we can schedule pods to it. We can basically the structure of the job. It can be found. You can find it in GitLab CI documentation. I will refer to some things here about the syntax, but most of the information can be derived from that. Here I'm showing you how you can take what we already made, copy it, fine-tune it in order to make things better. There is also the variable check that checks if you have API configured as an environmental variable in order to enable you using the features that automatically imports the tools. There is also a container builder where we take Docker files and using a technology named Kaneko made by Google to build containers from Docker files inside containers, making the infrastructure as a code. So everything every container we build that does some obfuscation or building method can be stored as a code as well and updated or de-upgraded in just few commits. And the last job that we're seeing here comes from the tools import YAML, where it basically takes a JSON file named the tools index and checks which projects are not exist in our GitLab instance. And if they not exist, it imports them. And this one uses the API. Now, if we take a look at the tools index, it's a JSON array that contains the tools Git repository URL, the name we wish to see in our GitLab instance, the visibility, whether it's private to the user who imported it, to anyone in the instance or to the public, and also the config path that define the flow on how to weaponize this tool. And for every tool we are importing, we must have this file. Now, for example, the Rubius tool, we can see that it has few inclusions and 3 stages: build, obfuscate, and deploy, which are done inside YAMLs that we are referring. This is the modules I was talking about. Now, if we take a look at the tools index, So the first one is Tools CI. What the Tools CI does is building C# tools. It uses an image containing MS-Build, and it runs on a Windows node. The image is stored in our container registry. And it can pull it without any problem because of the permission in the GCP and use it. And now we're using MS-Build to build any tool with the release configuration. The environmental variable, it comes from our Rubius because we need to define for the next job to know what we're going to build. I want to just pause here. The last area that you're seeing here, starting from the CURL, is a workaround we made because GitLab did not support running Windows containers on Kubernetes. So as a workaround, we uploaded the artifact from the build, from the obfuscation, manually ourselves. In the next release, we will be able to use the same manner that GitLab intended to use to collect artifacts from the job. And we will update the repository so you can use it. And I will show you later in a Linux-related job how the artifacts looks like. Let's proceed. So this is the part where we upload the output, the executable, into the job artifact. So the next job in the pipeline, the next stage, will be able to pick it up and do the obfuscations and the other stuff. Everything here is with environmental variables. So we actually can point there any tools given the correct environmental variables. Going to the Confuser EX job, where it takes executable and obfuscate it using that the Confuser EX tool. It takes the previous artifact, also because of the issue I talk about. And the next release, the artifacts from Windows as well will be downloaded automatically. The Confuser EX is also a container image that we made. And you can find the Docker file of it in the repository. And we just pick which modules of the Confuser EX we want to use, applying it to the executable from the previous job, from the compiled for the compiled Rubius, and eventually we upload it to the job artifact. So the next job of the pipeline will be able to take it, to download it and apply its techniques. The name of the file will be with the suffix confused. The last job here is at the point of deploy CI, which takes the files that collected throughout the pipeline and upload it to our file server that I showed you at the beginning, which is a very useful file server for serving payloads related to offensive tools. It runs on a generic Ubuntu Bionic, and basically it takes the right key and the URL for your PondDrop server. This is a thing we had to provide it from the first time. But here it won't work because we didn't supply it in the pipeline execution. Moving on. Write down your questions if you have any, and you will be able to ask at the end or the Discord. So going back to the deployment initializations, we can see that the jobs that checks the Windows and Linux existence passed. and the check variable job failed. We can actually take a look at the job log, contains a very verbose and detailed log to understand what happened and to build a better one or to improve it for the next time. Here we just use the container that does not include CURL. So the fresh Ubuntu Bionic container does not come with CURL. In other places, we installed it using the script section. Now, the build all container step basically takes all the Docker files related to Linux that we have and build them inside the Kubernetes and push them into the container registry. And the tools importer, as we saw, it takes the tools from tools index and update the GitLab instance. You can see that new containers were added. We had 3 at the beginning, naming with the same namings as here. For the tools importer, we'll now take a look at the main page to see new tools added. Let's execute a pipeline of a real tool. If you go to the Rubius repository that we just imported, you run its pipeline, which is pointing on a YAML flow format, recipe format in another repository. This is a very useful feature because we don't need to change anything in the original repository tool. We can see the 3 jobs added, the build, obfuscate, and the deploy stages. And the deploy would not work because we did not supply here as well the credentials to upload to the Bruno. We'll do that later on the next pipelines. Behind the scenes, we can take a look at the cluster, the Kubernetes nodes, and see that we have the Windows node provisioned where the build container, build pod is running over it. The 2 other containers here are for the GitLab runner intermediate connection through the GitLab instance, and the running container is the one that actually creates this bubble job. You can take a look at the events and see that it pulled the container registry that we aimed at, the container image that we aimed at. In GitLab, they also pull helper container to do all the job of the Git cloning and the artifacts uploading. Now, looking at the job log of the build operation, we'll be able to see all the MS build verbose logs about the successful build of our Rubius tool. And also the uploading of it into the job artifact where we can access it through the right pane and browse it. We don't serve the files from here, but this is for debug and development purposes. Now, once the previous stage completed, we have the obfuscation job, which started. Same thing with having a pod over the Kubernetes cluster. It creates the container. It takes time to download the container image from the container registry. It pulls the confuser EX windows. Now we can see the logs of this one. Jumping the waiting time. Okay, we see that successfully took the Rubius tool, the executable from the previous phase, and executed the confuser CLI over it. Eventually upload it to the job artifact, which will be available for us on the right pane and for the next job to take and perform its operation. Now, the amount of jobs and stages you can do is countless. You can do few obfuscations, encryption, decoding, loading in other ways, prepare the tool to be transferred into a targeted network, and have a one-liner that decodes it and executes it. Let's say we want to import a new tool. We go to the tools index, and all we need to do is to copy, to create a new object with the new tool we wish to import, taking its repository Git link, giving it a name, set the visibility to internal, and also point it at its recipe, at its YAML file that creates its flow. Now, we don't have this file already, so we have to create it. And this is the flow of creating and adding new tool into your operations. So we name it CERT.LV, and we will have to create that under the tools controllers. Because this is also a C# tools, it will be very identical to other C# tools. So we can basically copy another tool flow and just change the environmental variables and include stages that we wish this tool to pass through. And here we will use only the build stage. For the first time, we try to just build, and then we pass on the other phases. Now the executable name will be same as the solution name. And we have to specify the path for it, of course. And for the release folder, we actually can take a look at the csproj file. If we do release configuration, we can see where it located, the output path, and copy from there for any C# tool. Now, all we need to do is to commit the things that we've made, the changes that we've made, and the framework will automatically create a pipeline that will import the new tool. Jump over this one. Okay. You see the changes and the tools index and the new added sharp block. New added file sharp block content. Here it's nothing changed, just another space or something. We now commit into the main branch because we set it to read from the main branch. And at the bottom, we can see that a new pipeline is pending. You can click it and go directly to the job that was created out of this commit. It initiates the pod with the container and all the instructions. And it will automatically download the tools index, check for the new tools that added, import it, and we'll be able to see it and execute his pipeline. Here behind the scenes, you can see as well that it's another container running on the Linux with the Ubuntu latest container. Jumping over the waiting time, and we can see that sharp block was imported successfully. Now let's execute sharp block's pipeline. You can locate it in the list. Go to CI/CD, pipelines, and run pipeline. It will contain only the build job because this is what we defined it to do. And it starts, it will run the MS build over it and will complete. Now we want to see another feature, which is multi-pipeline YAMLs. I want to show you how you can execute multi-tools pipelines. As I said, for a specific set of tools or all tools, or if you want all your 5,100 tools, every engagement to be obfuscated and encrypted and pass all this flow, you can use this approach to save time. So this will be under the CI multi-pipeline, created here file name ad.yaml, which triggers and adds jobs into a pipeline only when they meet the specified criteria with an environment variable. Now, this is the Scalops recipes repository. And when we execute the Scalops recipes pipeline, we have all the maintaining and all the framework itself feature. So if you want to run multiple tools pipeline, and we placed it right here in this file, we will see that it comes on the latest stage of the Scalops recipes while referring to the ADYAML. And what we need to do is run the pipeline of the tool while specifying the set of tools that we wish to build. So under CI multi-trigger, we can specify AD Windows MS SQL. For this example, we will do all tools. So we'll see. You will see multiple tools getting built. And now we want the tools to be deployed to our file server. So we need to provide it with the file server, the pointer of file server write key and URL. This is a slightly customized Pondrop server that you can find in my GitHub repository. Now, running the pipeline will execute the other jobs that are triggered with having the CI multi-trigger parameter. As you can see, they're added to the multi-trigger stage, and they triggered pipelines of other repositories. The other pipelines will be under the other repositories and not under the Scalops recipes. We also added the tool, a Go tool, for an example of building Go tool, PowerUp SQL for PowerShell example, and the Rubius, which acts as the C# tool. skipping the time, we see that everything was succeeded. And it means that all the files, all the artifacts, all the tools has to be deployed into our file server, right? Let's see. So we have new tools. We have the Go tool. We have the Rubius after being confused with Confuser EX. And we have Power Up SQL, which pass through an obfuscation of Chimera. The last thing I want to show you, before the last thing, I want to show you the last thing is the Docker builder. Let's say you want to support a new technique and you want to create a new container for that. We can create a Docker file that will be built inside the framework and pushed to our container registry, where we will be able to use it on another one. We'll use the Chimera Docker file, but we will base it on a different Linux source operating system. Instead of Ubuntu 18, we'll take the Ubuntu 20, or we can just state the latest. Let's say we want to upgrade our dependencies. That is the way we would do that. We will commit this code into the main branch. And now, because we want to use a feature of the scale-up recipes, we go to the scale-up recipes repository, run its pipeline, find the relevant parameter that builds a Linux container, state the prefix name before the .docker file, and execute the pipeline. The framework will be able to identify that this is what you want to do, and will add that job only to the pipeline to build your Linux container and push it into the GCP container registry. So now we'll need to see a new container named Chimera 2 under our container registry. As you can see, we have the Chimera 2 here. And this is the last feature I wanted to show you. You can think on many features, on many things. It's a code and it's computer. So you can basically build everything you want and also share it through the scale-up recipes Git repository and make it like a community-driven platform. Let's proceed. So everything that goes to the cloud raise the question how much it costs. And this is very tricky here because there is an idle time where you don't weaponize tool, but the framework is turned on, and you have like the per job, per operation credit that you will have to use. And if you're not planning on providing tool to the entire community industry, the offensive community industry, you should end up around $100 a month. It also depends on the amount of time that you have nodes in the air. If you have more than one node in the air, it will utilize at least another $50. And the Windows related nodes are cost even more than the Linux ones. So try to stick to Linux related jobs because it will be faster and with more efficiency and also cheaper. I also listed here references and to the technologies that this framework leans on. You can go ahead and extend your knowledge. And that's all. Thank you very much for joining this talk. I encourage you to go and try this repository. As I said, next week we're releasing the new version with the support for Windows. And you can reach me, ask me questions anytime. Thank you.
All right. Thank you, Gil, so much for explaining the massive work you've done together with your team on this. I'm going to now carry on with asking you some questions and asking for your opinion maybe on some things. Now, as I understand here, the GitLab is the central tool that allows us to kind of centrally manage and automate it through the pipelines. Now, however, your talk focuses on the offensive part. However, I understand it can be automating or maintaining anything, right? It can be defensive, it can be just a matter of tooling, right? So how easy it is to adjust or adapt the thing that you've created to any other approach.
So the gross amount of time I spent on understanding the benefits of the system is around 3 months, where I tested many things. I tackled a lot of problems. For example, the GCP comes, the Windows node, related node comes with Windows Defender, where it deleted directly right after building our artifacts. And we thought we're done. We have to do that without containers. And yes, you can do basically anything. These systems are built for creating application and serve them in minutes right from their sources by changing only a bit of code. You can also incorporate tests, and you can also put alarms that will go and notify you after things are done. You can download repositories, compile tools. If you're talking about the defensive side, you can download repository, compile the tool, and extract the hashes. You can create an automation that builds Yara tools over obfuscations of different tools. For defensive, there are also a lot of possibilities here.
Right, thank you. Now, in the demo that you showed that certain Git repositories can be just acquired, stored in the description, and then once you run the pipeline, it will be downloaded, executed, and integrated in whatever you've required. Now, the question comes here. Now, not always the latest version is something that we need. It might break some backwards compatibility, or it might break something else. How would you handle this here as well?
So that's the great thing of having a version control, because if the original, the developer of the tool changed something, we can go back to the previous commit. And also, when we push new containers to the registry, we don't delete the older one. We just put another latest container. And we always can go back to the earlier stage we've been to.
Right. As a final question, so when I'm automating something for offensive operation, this means that if it is a fixed approach, it will mean that it's something that I'm revealing my TTPs, tool techniques and procedures. Is that something easy to adapt and modify here? So for anyone else who is trying to chase me, defenders, it's harder for me to identify and fingerprint.
So here is just an example of things you have to do. We don't release in the scallops recipes all the techniques and the tools that we're using. It's just selected tools and techniques that are very common we use. And we really wanted the community to do the tools, wrap the techniques, package their techniques in this way, like people do with the Cobalt Strike Aggressor, for example. And in that way, other people can, even if you're in a defensive guy, you'll be able to easily weaponize a tool and run it and see how it works.
Right. Well, thank you. Thank you for the contribution to the community. The work that you've invested is really, really highly appreciated. Thank you for the talk.
Thank you very much.
Thank you. And we return back to the studio. This is just 10 seconds away until we close down the capture the flag, which means that these are the final 10 seconds to submit your flags and maybe go for the winning position in the top 3. However, in just 5 minutes, we are going to return back to the studio with yet another talk, so stay tuned, and we'll be back here soon.